So I don't know how I feel about this, but my girlfriend has started getting these like canned coffees, and it's a little weird because I feel like it's wrong, but they're putting them in these like these like beer bottles.
Yeah.
So I don't. It's like it's 7 o'clock in the morning, and I feel like I'm putting one back. So
No, I mean I live in France. I mean coffee is just another religion.
Yeah, exactly. So are you a big what's your morning like? See, this is when I think of of course you probably have a different life because my experience with France is as a tourist, right, where everybody wakes up in Paris and then goes to a cafe every morning, right? So what's your morning like?
Because I tend to work with the Americans all the time, the mornings actually is more of our evenings. So it's bring a coffee back to bed and sit there with my wife and reading the papers.
Yep. Why am I showing this? I don't want to show this. I want to show you guys the stuff that makes you believe that I'm so super prepared. Hold on. So in terms of coffee, what do you do?
I do have a coffee machine downstairs.
Yeah. I got my better half a coffee machine for like a grinder and like an actual like coffee maker for Christmas a couple of years ago, and she's gotten pretty savvy with it. She won't let me touch it ever.
Yeah.
But she's sometimes it just takes a lot. You got to get the beans, you got to do all this stuff. So sometimes it's like, I'm just going to buy you a can of coffee. So anyway, all right. Well, welcome everybody to DevHead's Weekly Office Hours. Today is Friday, September 27th, 2024. Glad to have you with us. Today we are going to be getting into choosing the right hardware platform to jumpstart your design. Essentially, I'm really curious how everybody in the group uses, or when they use a hardware development platform, when it gets into their design cycle, what class of or type of platform they select when that happens, and why. And then if there's ever a need to jump, say from like proof of concept to prototyping to MVP, when you make the switch over to something else. But before we get into that, we'll go around and do introductions. My name is Brandon Lewis. I've been a technology journalist for about 13, 14, 15 years, somewhere in there right now in the mid-teens. And I'm really fortunate and pleased to be part of the DevHeads community. That's me. Zacck, you want to go next?
Hey everyone, I'm Zacck. I'm a software engineer. I've been doing it for a bit over a decade now. Happy to be here. Yeah, awesome.
Umesh, you're up.
Hi everyone, I'm Umesh from Pune, India. I've been building embedded software and hardware from past 10 years for IoT solutions. Thank you.
Cool. Ming, your turn.
Hi, I'm Ming. I've been a Unix and Linux consultant for over 30 years and an embedded Linux in that sphere for over 15 years now.
Great. Ahmed, you're here and you're on mute and camera's off, so I won't ask you to introduce yourself, but hello all the same, and hi to everybody in the chat and wherever you are in the ecosystem, DevHeads ecosystem. So like I mentioned, this is really about, today's session is really about, what hardware platform do you use to jumpstart your design? Where does it come in? And, then do some of the maker, hobbyist, student boards, which have all sort of advanced in one way or another to get closer to commercial, at least some variants of them, commercial grade. When do they become insufficient, and what's the switch, and what do you do? So that's basically the synopsis of what this slide says. But the first question really is, what's your development process for you, your company, your clients, and when does hardware first show up? So we'll start with you, Ming, since you're a consultant. When do you typically encounter the need for hardware, or do you always encounter that need?
Don't always. It depends on the project, and it depends on the specifics of the hardware. If it's like a generic system where it's just going to be a bit of Wi-Fi, a bit of Bluetooth, I'm actually probably going to start my development on a PC.
Very good.
And just get the ideas together before even shifting to an embedded system.
At what point does the embedded system then come into play? I know you said it depends on the project, and it's of course it's like everything in embedded it depends. But is there a certain point, where you reach, you're like, okay, I don't have any choice now. I got to slap this onto something, and then at that point, what do you choose? Do you go for something that's like the super cheapest, easiest way to prove out what you're trying to implement, or do you go with something that may be a little bit closer to your end design?
When I make the switch, I mean, it will be, as I say, it depends, hardware, whatever. But when I make the switch, I will tend to go for the cheapest board. Mm-hmm. So I will start at the lowest level. So I'll go and grab, because I mean, I have the BeagleBoard Black is my go-to board. Mm-hmm. So I'll start with that and see, is that good enough? And then start going up from there if I'm running out of power.
Awesome. How about you, Umesh? So, when do you start, in the development process, needing to get onto a hardware prototyping platform, right? And, what's the switch there? What are you selecting? Is it like Ming, where you're going with the cheapest, lowest cost, lowest performance that'll suit your needs, or do you do something different?
For me, right?
Yep, for you.
Yeah. So in case of Ming, I think we understand because he works a lot in the processor things. So for me, because many of my product uses a microcontroller, we as a company basically open enough to use even a breadboard sometimes, because sometimes you just need to test a power circuit or something which you have not used it, and that's very unique. So we use a breadboard as well for prototyping. But then when it comes to development board, we use for the normal designs, which is because it depends what you're building. As an experience, 10 years, many of stack are well tested for us. So we know exactly what board will be used, some nano based, or I'm talking about Arduino ecosystem, because Arduino has introduced this nano, which is very small form factor. Right now, the Pico style boards are also getting popular because you don't have to waste your time and energy to understand about the clock and then the power circuit and everything. You just put on your product, and then, I mean, you design your other circuits rather than designing actual microcontroller based circuits. So we tend to prefer something smaller form factor, very, very small, like as I said, Arduino Nano or a Pico style of board, mini board, basically, for the prototyping. Yeah.
Great. And at what point is that showing up? I mean, are you going from whiteboard straight into that Pico class board, or is there some development, like Ming was saying, do you get into PC development first and then make the jump? Like, when does it enter your development cycle?
I think we tend to start with, I have very fixed cycle right now, because most of the things I try to build on the Arduino Nano style. Okay, and I test it whether how it should look and how it feels and everything. Then I straight away jump into STM32 styles. Let me just show you. Like, if you look at this little one, you see it has this nano, right? So I tested whether this software works or not, because it's on Arduino, so quickly can be done. Once it is working, then for serious development, I quickly jump into STM32. Right now, this is not for maker, right? It's written in a bare hell API. So I think that way we move. And then when it comes to mature prototype, we tend to prefer not to use nano or any kind of development kit. We remove everything and then go and make it smaller. That's where the actual customization start for us.
Do you ever ship a kit type or kit class platform into anything commercial? Have you?
Yes, we do sell a couple of solutions, IoT solutions. That's where we use Raspberry Pi's modules, because designing your own PCBs or modules or something for the microprocessor, it requires a level of expertise, right? And then making it the compact, which you can get it in the market from bigger brand like BeagleBoard or Raspberry Pi Foundation or something. Not you always want to waste your energy in designing something like that, right? You
Yeah.
can pick it, like you can even look at some sort of compute modules from Raspberry Pi, so they are good enough for production. And yeah, we ship it some solutions.
Great. I'm going to circle back on a question there, but before then, Zacck, how about you? When you are developing a commercial product, when do you, when does hardware enter the equation? How do you make the switch for your? Do you even go to one of these cheaper, lower cost Arduino, Raspberry Pi type boards, or and this is going to be sort of the coup de grace of this whole thing? Do you just jump straight into, like what Umesh was saying, more like a vendor specific kit that's maybe closer to the finish line? You're muted, by the way. Oh, you're frozen too. Can you guys hear Zacck?
Nope, frozen for me.
All right. Well, let's move right along then. Back to you, Umesh. So when you are doing development, why are you moving to an Arduino or a cheaper style platform instead of just going straight into ST32 in the first place, right? STM32. Why don't you just make that jump right there?
Because in my case, I usually give some interns to work on that, not me straight away work on that. So if they are not very good at that, then they probably take a longer time, and I don't want to waste my lot of energy and time to do that. So first, I think it's important because you worked on all those libraries, right? Every project comes with a different kind of technology to use and incorporate, and it really reduces your own time, because not everybody can finish everything. So if somebody can bring in half complete work, I can code it and I can do it, right? So I look at long term rather than taking up something. And if sometimes it's possible, I see something that we have used it and we have an experience with, then we straight away go with STM, right? Especially nano style. So it's not a problem. It depends. Like, let's say if I never ever have worked with LVGL or something, then I have to keep it simple in the beginning. I don't
Yeah.
want to take something and waste my time and then snap my head and say, okay, why it's taking so long for me just to implement small things in the beginning. So
Oh, we're going to get to this because we've talked about this before. Is it really the hardware at all? So, Zacck, we lost you there, but when you're getting into developing a commercial product, what is the place you start? When do you first realize you need hardware, and what do you start with when you do?
Okay. So previously, I would start with a Raspberry Pi. The reason is I was comfortable on that, and I learned embedded development as a web developer using a web language on a Raspberry Pi, and then I got comfortable with that, and then that's what I started with. And at some point, I moved to ST and got very comfortable with ST. I did this exercise where you write all the drivers for all the peripherals on ST, and then you kind of know how it works. And then at that point, I now start from ST. Another thing is Umesh's prototypes are really neat. Like Umesh has a complete product. That's a prototype. Whatever that nanoboard has, that's.
but I started the same way as yours, Zacck. If you look at, before I came to this one, it was the same on a breadboard basically. And the reason to go for nano is you can put on a breadboard and you can put 8 breadboards together, right? So there's no limit. So yeah, I mean, it's more presentable. That's why I chosen one that I built.
So for everybody, I put up a poll. If it's not taking over your screen or wasn't taking over your screen, you can find it by going down into the bottom right of the tool in the polls section. If you could go down there, click that. There should be a poll. Let me know if you can't see it. It says, when you begin a POC or prototype, what type of hardware do you start with? General purpose boards like Pi, or Arduino, or BeagleBoard, vendor specific kits, or emulation, or other. Why don't we just all give that a vote and see what everybody's doing. And it looks like, right now from the early returns, like 60% of people are starting with, a kit that are that's a maker or student or hobbyist. I don't know if you guys can see the results, but for me, I can. So that's pretty significant. And it's interesting if you are developing a commercial grade product, historically these were Arduinos and Raspberry Pis. I don't know. Do you think it's fair to say that they were viewed kind of as toys? They weren't really taken that seriously. How would you respond to that, Ming?
I would respond to that. That's actually one of the reasons I use the BeagleBoard Black. Because the Raspberry Pi is always considered a toy. But when I'm talking to my customers and I'm saying, well, I'm not using a Raspberry Pi, I'm using a BeagleBoard Black, and I'm taken more seriously. Or even when I'm going, so if they're thinking that the BeagleBoard Black's a toy, well, I'll switch to the Pocket Beagle. The Pocket Beagle is a lovely bit of kit that is really small form factor, and you can put it into all sorts of things. But it has that serious aspect to it.
That's a very interesting way of thinking about, or it's something that's happened in our perception, like our community perception of these, right? Like Raspberry Pi and Arduino are toys, and then BeagleBoards and BeagleBone is like not completely a toy, but not completely professional, probably somewhere in between would be called Maker Pro. And then you have the kits that are from the vendors, which are getting close to surrounding reference design type level, right? So it's interesting to see how people might progress from one to the other. Umesh, I think I know your answer to this, but are these toys? Are Raspberry Pi and Arduino and BeagleBoard, are they toys or are they real deal? With the grain of salt that you're shipping Raspberry Pis.
I think this is all about perception, and what Ming says, I completely agree with him, because I too face sometimes clients with these questions, like if you're using Raspberry Pi, then thank you very much, or something like that. But I don't think they are a toy. It's what you're building that's important, and then how stable it is, that's important. Now let's take an example of Arduino. Even before Arduino came into market, I remember 2008, 9 or something, 80 mega 328 or 80 tiny or something Atmel series of controller are very serious controller. I myself worked in one of a product in Europe. They used to make healthcare product, and we were using Atmel chip by just connecting over I2C protocol a pressure sensor to read a pressure data, and basically it's a healthcare product. So I don't think it's just because of the Arduino and the libraries and because it's been used for education, it's become like this. So it's all up to the skill. So if somebody can write very neat software, then it's not a writing software for even Atmel's chip is not a piece of cake. It's a difficult sometimes who write a code they understand. Mm-hmm. Even I would say, if you ask somebody to modify Arduino library, it's a clear pain will be seen on their face, because to modify the library, they can use the library, but when it comes to modify, then you need to know everything, and then they say it's a serious game.
Yep. Ming and I were actually talking about this right before the session started, about publishing all of our slide decks and putting a process in together or put in place so that everybody could get access to the slides for like tech tips and some of the engineering hours and even these office hour sessions. And it's just overwhelming how, if you apply that same sort of thinking to what's happened with Arduino, you even said it yourself, I don't want to deal with this, so I'm going to give it to somebody who's got less experience maybe to start their development using Arduino because they're familiar with the Arduino IDE. But eventually that becomes a groundswell that takes over, right? Where now, is it acceptable to use an Arduino IDE, C++ in embedded development? And I think increasingly the answer may be yes, just because there are more developers that are comfortable doing that. I mean, Zacck just said, the way that he entered embedded was through a higher level language, right? And increasingly, it seems like that's being that's influencing the way that embedded systems are developed. What would you say about that, Zacck? Would you say that the software ecosystems of these platforms are starting to change the way that embedded systems are developed?
I don't. From speaking to my elders like Ming and Umesh and seeing how they used to do things and how things are done today, I don't think anything is changing. The thing that is, sometimes we conflate two things. There's the Arduino users, and then there's the Arduino platform. There's people doing rather critical systems in Arduino right now somewhere out there, because you can do that. But then there's a group of people who are trying to make cool things, not functional things, but think my room, blinking LEDs, everything. It's cool and it is what, but it's that kind of person that we think about when we say, is Arduino a toy? It's not actually the platform itself. It depends on the user and how the user is using it. That's the way I see it, because there's nothing new under the sun.
How about you, Ming? What do you think about that?
I would actually agree with that as a concept, in terms of it's the user that is going to be coming from an ecosystem. And you've got, as with any compute system, your general purpose users. So they would be the person, they're going to use Excel, Word, and an email and a web browser. And then you've got the power users. They're the ones that are going to be more interested in what's coming, and they're going to start scripting. And then you've got the ones that are going, well, actually, even scripting's not enough. I need to do more than that. I need to start writing my own tools, my own libraries. And you'll start with the Arduino, you'll do it with the Raspberry Pi. You'll get all of the tinkerers, and people are going to come to their own level as to how interested they are, or in my case, are people willing to pay me to investigate more?
Yeah. Moving right along, then, do you? I mean, from that discussion, I guess the answer is to this question of, do you consider these toys having a place in professional development? I guess the answer has to be yes, and it just depends on the user. I mean, I guess really anything could be a toy. A hammer could be a toy if you're playing a game with it, right? So I don't know that there's much else to add to this besides what are the advantages and disadvantages of getting in, Umesh, of starting your design with these, Umesh?
I think some of the, I'm not saying that I would gonna use this module straight away into the solution that I'm building for IoT. I just want to be clear for the viewer to understand these companies are increasingly working hard these days to create a production grade hardware. So you cannot use Raspberry Pi straight away by saying, okay, you use Raspberry Pi for development and testing. It doesn't mean that Raspberry Pi's compute module, which is a production grade, can go into the solution, right? So you have to understand what you cannot just by looking at one aspect of that. Of course, to what Ming says, the client would often be reluctant for this. So that's why we tend to build some of our own PCB, some of our own system on which the module can sit in, right? I'm not talking about Raspberry Pi's case, but very often I tend to prefer customization just to convince them, okay, we took care all what you're worried about. So don't worry, it works. So that's what I wanted to add. There are production grade hardware from these companies.
Yeah, and I didn't even share my slides with you. Let's see. Oops, let's go back. Where did I think I may have missed one slide, but I had Yeah, I had a slide that was just about exactly what you just said. It had some specs of all of these platforms. So let me see if I can pull that slide back up. But yeah, I mean, I think then while I'm doing that, Ming, what do you think the advantages and disadvantages are of using Arduino or Raspberry Pi or BeagleBoard in commercial grade development?
I think it's perfectly viable to the extent that I've done it. I've shipped things with a little the Pocket Beagle, and that was wrapped up in the package, wired up to the displays, and that was our product. So it's definitely got a place.
What about you, Zacck?
I have not designed a custom board yet. Everything has been shipped on the blue bill. No, I'm not a hardware engineer. I'm going to be honest. I can figure it out, maybe, but I've not tried.
Here, let me share this slide with you guys real quick. It's a little half baked, but it'll have to do. So
I just want to add something. It's amazing to see that the blue pills and black pills, I don't use them, but I love the way they put Type-C USB very quickly. And this generic board from ST couldn't able to do these changes. I love the way this market moves, and this kit fills the gap which companies couldn't able to maintain. And yeah, but for the clients, you try to stay with something more branded, in my case.
So here's exactly what I was talking about that Umesh sort of moved into, which is, these are in the text above here used to say, all of these companies are starting to create commercial grade products. So it's hard to differentiate, at least to me, right? You've got the Arduino Pro line, right, that are clearly trying to be professional. As Ming said, the BeagleBoards have always been a little bit more on the, higher reliability, higher performance end of embedded development. And, here's some specs for BeagleY AI. And then Raspberry Pi Compute Module 4, while not everything on it is necessarily where you would want, where you'd feel completely comfortable shipping at least a semi-long life system, more than a couple of years into the market, you are starting to get performance levels. You're starting to get some of the things that you would expect to see out of a, out of a commercial grade solution. So, I mean, I guess the question then becomes, and I'm not going to ask you, Umesh, because you already told me the answer, but Ming, I mean, how comfortable would you feel shipping one of these things?
I have done, but coming back to the standard, it depends. Mm-hmm. See, most of the stuff that I will ship will be a bespoke board, but that's because we're trying to get into a particular form factor. We'll take a BeagleBone as our base reference, because for me, one of the big things from the BeagleBone is the open source design. So all the schematics are open source. So I can breadboard, I can add in the features, I'm adding in the components, so I can breadboard that and then hand that over to an EE and say, now give me a PCB that does that, please. And then we can put it into the right form factor so that it's got the right enclosure and it has the prettiness, because aesthetics are important when we're coming to solve stuff. And for that, it tends to be you're going to want to have a customized PCB.
So at that point, what is the difference and what is the place then of a vendor specific kit, right? Okay, well now you're probably more likely to be able to get a kit for a specific SKU that you're looking for, right? And I guess the traditional way of thinking about this is saying, BeagleBoard, Raspberry Pi, Arduino allow you to get your proof of concept up and running, and then you would move to a more optimized solution, which would probably be on a vendor specific kit. And then you would start spinning your own board, right? But is there really a need necessarily to go to a vendor specific kit these days, or can you just go from BeagleBoard to spinning your own?
When I'm dealing with the BeagleBoard, I tend to go straight from the BeagleBoard to spin my own. It's when I've been starting with things like an NXP that we will go for the manufacturer's dev kit and we'll prototype it on that. But that's because it's a slightly different format of things.
How about you, Zacck? What do you think?
Wait, repeat the question again, so I'm clear on what I'm.
Sure. Yeah, it's basically when you are these days, when you're thinking about the availability of kits like this, like these pro versions here, is there really a need anymore to go from a Raspberry Pi or Arduino or BeagleBoard to then a vendor-specific kit, like a kit from NXP or TI or whatever that has, whatever that vendor has provided? Or do you think that you could jump straight from, and it's interesting to hear you, do you think that would you feel comfortable jumping straight from like a POC platform, like the Arduinos, Raspberry Pis, et cetera, to whatever you're going to deploy in your custom end product?
I think I wouldn't need to go like Raspberry Pi and then something like a Nucleo and then like product. I would just go straight from the Arduino board or whatever to product. I don't see the need for in between unless you're doing something like Ming described. You might be developing a product where you can do quite a bit in software. So you want to kind of prove stuff in software. And then you could go to Linux. You could just do stuff on like some Debian derivative, and then I can drop into some Nucleo and then make my custom board. So it depends. Like Ming said, it depends, but it would depend on, can I do a lot in software before I need hardware, after the answer to that question leads to the other one there.
Yeah, Drew in the chat says, I feel the need of going to vendor-specific boards would mainly come up if people asks for it, and at least that's his experiences. How do you guys respond to something like that? Is the utility of a vendor-specific board either we're trying to optimize on a SoC that isn't available from the general ones, B, your customer asks you to do it, or C, none of the above? Ming?
For me, I would do it when the customer asks. I would come into a company, and if they've already started the project and they're already a little bit down the line and they've gone down the actual vendor board, then I'll work with that vendor board.
How about you, Umesh?
Yes, same answer. Because if your client asks you, because he's the one who's gonna give you money in the end, right? And there is a timelines, you can clearly talk about it and then get it clear. Otherwise, just leave it. The one point that I want to add is vendor-specific kits sometimes comes with some feature, some sensor that kit is optimized for.
Right.
Okay, some unique, because anyone who create even a kit think and ask themselves why I'm creating this kit, why I'm building this kit. So if that is the case, if that kind of, let's say if I'm building a Bluetooth based product, I cannot expect this off the shelf microcontroller and processor board to give me the feature of the Bluetooth which NRF can give me. So in that case, then I have to go, whether I like it or not, that's a different story. Yeah.
What I'd just interject there for when you're looking at something like a Bluetooth. Now, see, for me, that's actually a slightly different thing because I've got Bluetooth in quite a few of my designs. So when I'm prototyping it, I'm going to go for the reference board of the Bluetooth chip from the vendor. So for the individual components, I'll be going for reference boards, whereas I probably wouldn't be going it out of initial choice for my main bit of hardware.
Right.
Yeah.
So that's interesting because what I think of is, all right, well, you're going to have tools and you're going to want to optimize for whatever the components are going to be there. But I guess for you guys in your development cycles, that's left to once you've started spinning your own board, and that's where a lot of the optimization is going to take place. Is that correct?
Yeah.
Yeah.
And also the design is, whether it's for controller or processor, is very important for anyone to understand, because in the world of processor market, your underlying operating system take care of that. In the world of microcontroller, you change something, you have to write the firmware from scratch, right? It's a whole different game. And if you're in the processor, if your operating system takes care, then uh, you just have to take any hardware which is popular one, and the driver gets supported, right?
Yep.
So we have to understand this. There is a difference in this design and product.
How about you, Zacck? You look like you were going to say something.
I'm agreeing with Umesh, because we have to differentiate processor land and controller land. Because in processor land, then you wouldn't even go to the Arduino Pro is a MCU based board, but at the same time, in this conversation, we are comparing Arduino Pro and BeagleBoard as the same thing. So you could even just start from the vendor specific kit, depending on the feature you want, and then you go from there. This will be especially the case if you're in controller land, not processor land.
It comes up to me, and this is the conversation has been good, and I just went with it. So we were jumping around a little bit. When you start getting into vendor specific platforms, you also start getting into vendor specific development environments and tool chains. And I wonder if that is, too limiting. I mean, is this one of the reasons, for example, Ming, that you just steer clear of it altogether until you have to get to, until you have to start doing optimization? Is because, oh man, like now I'm stuck in TI's SDK or Nordic's SDK or whatever.
For me, for things like that, I'm going to bring it back to Yocto. I'm not going to be using their SDKs anyway. I might use them as a reference, but I tend to be, one of the first things that I will actually do is I'm going to build myself a Yocto, and that becomes my base system that I'm going to be doing my development, so that I can then add in the features that I'm needing as I need them.
How about you, Umesh?
I agree with Ming.
You're not a Yocto developer. You can't agree with him.
Oh yeah, I mean, that's why I made it clear earlier. There is when we are talking about this, we have to get it very clear. The controller world we are talking about, or the processor world we are talking about, and most of the development processes doesn't change it, because we know what the controller and the processor is, right? So some things for the processor, the question doesn't make a sense sometimes. For controller, if somebody can ask that. So.
Yep. Zacck, anything to add here?
Some while ago, I was struggling a lot with an LVGL driver. It's a while, really, maybe a year or so. But what ended up happening is I tried for weeks and weeks reading data sheets and reference my guides to figure out the driver, and I couldn't. And then what happened was I went and I read Arduino Adafruit's code, and I could see the mistakes I was making immediately. And I see, like, that's the spot where I see I don't want to use the vendor specific tooling and stuff, and I try as best as I can not to use that, but I leverage it very heavily as reference material. Like, I will not try and figure out how to write a driver if Adafruit has written a driver and I can just read and transpile it into my language or my system if I need to. And that's where I see the space those vendor specific tools occupy. I use them, but in that way.
Great. Let me just make sure that so here's my beautiful final slide that I just recompiled very quickly. But yeah, I mean, when is it time to make the switch? And I guess what we've sort of landed on today is do as much as you can in the lowest cost, most accessible, easiest to use, fastest, most enabling platform, which tends to be, those on the left of this slide. And then if you've got to go into, very specific, piece of silicon or feature or whatever, that's when you might want to be making the jump over into, the vendor specific board land before going on to your own custom solution. Is that what you guys would recommend? Is that pretty much in line?
The only thing I would just say from a cost perspective there's also balancing the cost of hardware versus the cost of time. That there are times when it is actually better to go for a little bit more expensive hardware because it's going to save you development time. And these days we're not cheap.
Yep, that's for sure. Yeah, that's a good point. What's a couple $100 on a development board when you've got Ming or Umesh working on it for 100 hours? Okay. Sorry, what was that, Umesh?
And I want to add, this is very different world. So let's say if I want to design an hardware even for the prototype, and if I'm working on a chip, which for that I need to have some sort of hardware design tool, which costs me $7,000 license, there's no common sense in it. I would go and buy $100 kit, right? So when you are entering into commercial land, it's very different how you make the decision. Then it doesn't even make a sense, right? Like even software developer, how much does it cost to write the software? You can rewrite the software if that can be done in, let's say, 15 or 30 days of your developer, and maybe in $1,000 or $2,000 or $4,000 that will be cost. Now it depends on which country you are, how experienced your developer is, but I think this factor has to keep in mind. Otherwise I'm a little bit careful, then the answer would go wrong.
Mm-hmm.
Right, whatever I say could go wrong, and then it doesn't look good. Yeah,
for sure. Anybody in the audience have anything that they want to ask the panel or anything that they'd like to add? I saw let's see, I saw that you Fatima, you were typing a couple of times and maybe never hit send. But anybody have anything that they want to add to the conversation? Drew, thanks for your input here. He says the switch is needed when we scale, right? That's when you want to make the switch. So if there is
another point of making a switch, because I deal a lot with startup companies. So the switch also happens when you've prototyped it, you've breadboarded it, and you can now go back to the investors and say, it kind of works. Now give us the money so that we can switch to doing it properly. Mm-hmm. And that's in the startup world, that's a big time for the switch.
Yeah, that's a really good point. All right. Well, I don't think there's anything else here in the chat or questions. If you do have them, feel free to shoot them out. So I'm going to start integrating the community questions again next week. So I've just sort of been leaving those out to get through the amount of content that we've had, because some of these have been going to 55 plus minutes. But I'm going to try and get those back in, because after all, we are a community and we need to make sure that we help each other out. So until then, what we can do to get 1% better by next week is that I think we can also start integrating or making the slides available to everybody, like Ming and I were talking about before the session. Anything else? Anybody have any suggestions that they want to give to the community for how we can improve? Sorry, I'm switching back and forth. Now, Mai says...
Mai's got a good question.
Yes, I was just going to read that. For someone getting started, what's the best kit to start on to get more experience? Unfortunately, the answer is it depends. So Ming, do you want to go first?
Well, it depends. Are you looking at an embedded Linux, or are you looking at a microcontroller? If you're looking at embedded Linux, then I personally highly recommend going down the BeagleBoard route, because everything is open. and you've got the complete ability to dive into every bit of it from the bootloader up.
I'm going to try and grab a link to that, to the session we did the other day of RTOS versus bare metal versus embedded Linux, because that one will show you the type of applications that you might want to use one in or the other. So while I go and grab that, embedded Linux versus RTOS versus just programming, you may be able to correlate that to what the type of platform that you want to select is. But while I'm doing that, Umesh.
And say just one other thing is a cool thing of if you are wanting to get into embedded Linux, the Pocket Beagle, and then there is the Tech Cape. And that is a little board that fits with the Pocket Beagle that's got a bunch of LEDs, it's got some sensors, a whole bunch of things, and you can just put the two together and start playing. So it's a really good way of diving into an embedded Linux system.
I was going to put that down as a topic. I didn't think that we were going to have enough time to get into it, though, because it could open a can of worms. But it was about the Cape ecosystems, the add-on ecosystems that come along with at least with Raspberry Pi, Arduino, and BeagleBoard, right? I mean, so these are like expansion kits or expansion boards that you can plug in. And they really make it, that's a really dynamic element of these platforms, because you can get a lot more functionality in your proof of concept and prototyping. But Umesh, what's your thought? What's the best kit to get started?
Depends. If somebody is absolute beginner, like I have very different sort of experiences. I have seen an experience where you say plug in USB, somebody can put USB into some Ethernet connector, right? You don't know what kind of people you're going to meet, right? So the level, like where you are, that is very, very important. So if you are something who have never ever done anything in embedded, if you are starting at that place, then of course I would say Arduino is the best place to start. And then think about scaling towards maybe some sort of TI or ST path. I mean, whatever suits to you, in which demographic you are, what kind of market you have around you. So likewise, you should choose. But Arduino, I still say, make a sense. From there to navigate your path to professional development. So if you are absolute beginner, and if you know the basics right, then maybe start ST or NXP or TI even. They have some cool products for Wi-Fi connectivity. Yeah.
How about you, Zacck? I'm really interested to hear your opinion on this, just because, like you mentioned at the beginning, you're a developer who came from not embedded, right? I mean, I'm sure most people came from not embedded, but you're a developer. You started on Raspberry Pi. Would that be your recommendation? And then again, why?
I wouldn't recommend that you start on Raspberry Pi, to be honest. I think the jump is going to be painful, and not a lot of people will stick with the jump. If you start with if you make it look as easy as Raspberry Pi, and then you're suddenly doing register stuff on ST, you're giving up. So I think you want to do something like, my recommendation, and I'm the least experienced here, so take this with a pinch of salt. I would say start with the Arduino platform and use something like the actual one I would go for is 18E85, the tiny one, the baby one, the tiny one. Use that on Arduino, and then just try to do the same thing, LED or whatever, LED or pinging GPIO, whatever you want, whatever simple system you want. Start on Arduino, then go to not Arduino. So use CMake, do the linker stuff, do the stuff, so that you end up writing code from Notepad to your device without going through some big vendor system. And that will actually do most of the work. Like, you could just do GPIO outside of Arduino, and you would understand so much that you would be a different developer going back to the thing you're doing. So the board doesn't matter. It's the limitations and constraints you can put on yourself. Yeah. That's what I would recommend. Yes.
You
Yes,
go
Ming?
first, Umesh. 'Cause I've got a couple of.
I want to add one thing. Recently, I have seen a trend on YouTube. People spend too much time to learn about tool. So I want people also have to be very clear. Are you focusing on learning microcontroller or you are learning about tools? Like you straight away jump into CMake or GCC or AVR GCC something. Come on, you just get it clear. You are building a product. So are you learning about the microcontroller features? Then take a vendor specific IDE, write your code, get your things done, and learn about the microcontroller. And then when you are clear that you want to go expert level, then you can go into learning tools. So don't mix learning tools and learning microcontroller. Yeah, sorry.
Go for it, Ming.
Well, I was just going to say, because with Zacck talking about all of his Zephyr stuff, that I've actually gone and bitten the board as well, because I've actually been out and I've got myself one of the Arduino Unos, because it enabled me to be able to play around with the Arduino, but also it was supported by Zephyr. So I was able to use the one board, and I'm going to be playing with both micro or ecosystems to have a look at them. And so, because I don't like spending money on more things than I need to, the one board that does both seemed like a really good concept. So I'm coming down to join you in Zephyr world.
And just like Zephyr, he's trying to bring Linux with him, right?
Yeah, right.
I just added something that, based on what Umesh said, I added something in the chat that might be an interesting place to start. So we were talking with Christoph from Embeetle a while back around memory. Understanding memory might be a really good thing to start with, right? Because this is agnostic, right? This is going to be platform agnostic. And if you're programming something, you're going to need to understand memory. So there's a little quick primer on, some very basics of getting started with embedded memory. And, that might be something to consider starting with too. Cool. All right. Anything else? Anybody have any questions? Anything they want to add besides Zephyr FTW? All righty. Sounds good. So any suggestions? Anybody have any recommendations on stuff we can do to get better over the next week? I already said, Ming and I were talking about publishing these into the community. So all of the slides, and so I'll make a commitment to get that done in the next couple of days. Anything else? Nope. Okay. Sounds good. Well, everybody, as usual, thanks so much. Really appreciate your time. And I always enjoy spending an hour a week with you guys. It's a lot of fun. So hope you guys all have a great weekend. We do have a couple of sessions coming up this weekend. We have an engineering hour. With you, Umesh. That's right. We have engineering hour with you on Sunday. You got a little bit of an absence because you've been buying houses and stuff. Can you tell us what this weekend or this Sunday's engineering hour is about?
So this weekend, I will be showing anybody who is interested, by the way, using FreeRTOS with their Cortex-M microcontroller. I would be talking about the challenges when you use FreeRTOS to port and configure into your microcontroller project. So we have seen in our previous engineering hour, when you use CMSIS RTOS or something, and especially if you're using Cube IDE or something, click up the button, you add the middleware. But if you are using, let's say, STM32 or something, and if you want to use now a FreeRTOS, which is not a product of ST, right, or not even ARM for free, so how you can port the RTOS into the microcontroller project? So it would be amazing to explore the complexity of porting this FreeRTOS into the microcontroller project.
Great. Yeah, and so I just dropped a link to that event in the Discord. There, you can also go to the office hours live stream page, which has a bunch of all of our events basically in a little drop down, so you can access it there too. So feel free to sign up for that and participate. We'd love to have you on Sunday. And other than that, have a good rest of your Friday and Saturday too.
Cheers, everyone.
All right.
Thank you.
Bye all.
Good weekend.
Happy weekend. Bye-bye.
Bye.